Okay, so now let me go through how do we do this kind of flowchart questions. Now, if you look through the worksheet, many questions are this kind of flowchart questions, and it's very common for qualitative analysis. Usually, there's always one flowchart question for every exam. So how do we analyze this? Now, there are two methods. Usually, we either start from the top or we start from the bottom. So how to decide when to start from top and when to start from bottom? We start from top if the identity is known. That's to say, they tell you what is this metal or what's this compound that you start with. Okay, then you can make use of the known reactions to deduce what's the other things that's being formed. But in this case, it doesn't. Metal M is not known, so more likely you will start from the bottom and work backwards. Okay, now this second method is more common. Okay, so let me just show you how to use this. Now, again, what we want to do is look out for known reactions. If I look at the left and the right arm, sometimes there's no right way to start. I just start from the left. Okay, in this case, add sodium hydroxide dropwise, I get a white precipitate that dissolves in excess. To give a colorless solution. So what I will do is I will identify what is this testing for. When I add sodium hydroxide dropwise, this is actually the test for cations. So you look at your flowchart, test for cations, add sodium hydroxide, white PPT, soluble in excess. There are two, right? It will be zinc 2 plus or Al 3 plus / lead, depending on your syllabus. Okay, so there's two possibilities. Then we look to the right hand side. We see that when you add aqueous ammonia dropwise, again, this is the test for cations. White precipitate form, add excess, again gives a color solution, means it dissolves. So this will be only zinc 2 plus. So now I can confirm it's zinc 2 plus and not aluminium or lead. Okay, work backwards. What is this precipitate that was formed? Remember that the test for cations is the addition of alkalis to form metal hydroxides. So this will be zinc hydroxide. Same for here. Okay, then working backwards, to form zinc hydroxide, the hydroxide is given from the alkali, right? Then the zinc must come from somewhere. So that tells me solution N contains Zn 2 plus. For me to have a Zn 2 plus solution, my metal M must therefore be zinc. Okay, so zinc add hydrochloric acid gives me a salt solution. So what salt solution is this? Hydrochloric acid is HCl. So therefore, my solution must be zinc chloride. Okay, and this is acid plus metal gives you salt and hydrogen gas. Okay, so that's how you can identify everything here. Take note that when they say identify, it means you can either give the name or the formula. If they ask you to name the unknown, then you can only write the name. If they ask you to give the formula of the unknown, then you can only write the formula. Identify accepts both. So take note of the question's phrasing. Okay, you choose whichever you are more confident with, because if you write the formula wrongly, you will not get the mark. Same for the name. If you spell it wrongly, you will not get the mark. Okay, so then now that I've annotated everything, let's fill in the blanks. So just now metal M we say is zinc. I'll write the formula also. N is zinc chloride. Or ZnCl2. Know that zinc is 2 plus. Q would be zinc hydroxide, ZnOH2. Same for R. For X, we have colorless gas, hydrogen gas. Okay, so note it must be H2. It's a diatomic molecule, so cannot just write H or H plus. And you can see that often they ask you to write the equation for formation of something or the reaction with something. So the formation of precipitate Q, you can see on the left side. I add NaOH to zinc chloride. I get zinc hydroxide. And what is left? So this is where the bigger thing comes in useful. Na plus, OH minus, Zn2 plus, Cl minus. So NaOH, NaCl is left if zinc hydroxide forms a precipitate. Yeah, it forms a precipitate, sorry. So this is a solid, and NaCl is left behind in aqueous solution. So that's how you can write the equation for formation of precipitate Q. Now sometimes they ask you for the ionic equation. If I look at the beaker, right, the only ions that are taking part in the reaction are zinc and hydroxide. So I can actually represent the ionic equation in this way. The zinc ions, when they collide with the hydroxide ions, they will form zinc hydroxide as a precipitate. Then let's check whether this is balanced. First, to check number of atoms for each element. Second, we check the charge. Okay, so if you check the number of atoms, zinc on left hand side there's 1, on the right hand side there's 1. O on the left hand side there's 1, on the right hand side there is 2. So I should put a 2 in front here. Then you check H, 2H, 2H. Okay, correct already. Second, we check the charge. Left hand side, 2 positive charge. Okay, let me write the plus in front. Plus 2 plus 2 times minus 1. So overall is 0. Okay, plus 2, 2 times minus 1. On the right hand side, neutral. Okay, so the charges are balanced. So we can say that this is a balanced ionic equation. Okay, you need to know how to write the ionic equation for precipitation reaction, because this is a common question. You also need to know the ionic equation for neutralization reaction. Okay, state the test for gas X. This one you should know how to test for hydrogen. We do one more example. So if you look at question 11, you can see green solid A and dilute acid B. They react to produce solution B and colorless gas D. And okay, so here I can't start from the top because again I don't know what is my green solid and what's my acid, but I know it's an acid something reaction to give a solution and a gas. Okay, when you see test for gas, generally start from there because it's usually easier. Okay, we start from test for the gas. You see that it's bubbled into lime water. Then you need to know this is the test for CO2. What precipitate is formed? What is the identity of this precipitate? Sometimes they ask, so you need to know this is calcium carbonate. Okay, so test for CO2, a hot precipitate is formed. This confirms that the gas is CO2, and it tells me that whatever it was from was a carbonate. Okay, so it's an acid carbonate reaction to give you a salt solution and carbon dioxide gas. So the left hand side I settled already, the right hand side I settled already. Let's look at the left hand side. Now you know that it forms colored compounds, green solid, blue solution. Whenever you see a blue solution, always suspect it to be copper 2+. Okay, just have that suspicion in your mind first. Then we see that the blue solution, when reacted with sodium hydroxide, forms a blue precipitate. Again, sodium hydroxide is to test for cations by forming metal hydroxides. So what is my blue precipitate? It tells me it's copper 2 hydroxide. Working backwards, it confirms that copper 2+ ions was in my solution. Then they say to react with sulfuric acid. So copper 2 hydroxide plus sulfuric acid, acid plus base, gives me salt and water. So what is the salt form? If it's sulfuric acid, H2SO4, then the salt form will be copper 2 sulfate. Okay, then working backwards, the acid that can give me copper 2 sulfate must be sulfuric acid. And for me to get copper 2 sulfate as a salt, my solid must then be copper 2 sulfate, copper 2 carbonate. Okay, so if we fill in the blanks, again, it says identify. So either name or formula will do. A. So this is how I always approach the question. I annotate first, then I fill in the blanks. Okay, one by one. Acid is A is copper 2 carbonate. Now, is the 2 important? Answer is yes, because copper is a transition metal, and hence it can have more than one oxidation state. You will learn about oxidation state in the next topic, but for now, transition metals, take note, you need to write the charge in their name lah. So B is sulfuric acid. C is copper 2 sulfate. D is carbon dioxide. E is copper 2 hydroxide. Okay, then they ask you to write chemical equations for all those things. For you to know how to write D plus lime water, know that lime water is calcium hydroxide. Okay, so that's it for this worksheet. Try the rest of the questions yourself.